We're going to be looking at this quarter at doing something with scale factors and causing us to do some dilation with scale models. It's a really cool project, and a lot of students have had a lot of fun with this over the years in my classes. Now, you can do anything you want as long as it's legal and it's wholesome. Now, each set of calculations are actually going to be part of your 20% of your grade, and since there's going to be 4 sheets of calculations, that's 80% of your grade. So the majority of this is math-based. So if you're not doing too well with the small models and stuff, don't spaz out too much on that. It's really the math I'm most concerned about, but I really like to enjoy the projects you guys do create, and so that will be the 20%. Now, you do have to do 3 scale models and, of course, the math to go with them for the full 100%. Now, I'm also throwing on an additional 10 points of extra credit of wow factor. So if you really do something that's extremely attention to detail or very well decorated, or it's just wow, I'm going to give up to 10 points for that wow factor as extra credit. Here we're talking about scale factor, and scale factor is simply a single measurement that you're going to be using repeatedly while you're creating a scaling of something. Whether you're getting bigger or larger, you're going to maintain true to the scale factor. And if you've ever seen those scale models they use in movies and such, they tell you that it's got a scale factor of 100 to 1 or 64 to 1 or whatever it is they happen to use, and that keeps a consistency as they create all the different parts to these models. Well, your object is going to be to find something that you're going to want to compare to. So if you're going to be doing something related to a doll, you'd probably use your own height versus the height of the doll, and then you're going to make accessories for that doll. If you're making something to go into a little toy boat you've got, then you can compare the length of a comparable full-size boat to the size of the toy boat you're going to utilize and the stuff you're going to make to put inside of that boat. If you're doing something very large, like say you want to put words on a wall and you want to compare it to the writing on the Walmart there at your local house or whatever, you'd have to take the height of the Walmart and compare that to the height of the letters, and that would give you the ratio there, and that would allow you to scale it down to the height of your bedroom wall or wherever you're putting it, and that'll tell you what height you need to have for the letters. And so that's a basic idea of what the scale factor is going to be. Now, we actually have to calculate this factor, and so for what I did, I went out and I found a really cool Hot Wheels car first, and then I kind of reverse engineered it, and I went online and got the pictures and the data to go with it. So I picked up a 2012 Ferrari 458 Spider. Total sweet. Oh, if only I could afford that. But there's the picture from the showroom. That's a pretty car. And then there's the actual dimension from the manufacturer specification. So I've never actually touched this true vehicle, but I was able to get the information online, and that's going to be the case for most of you guys. If it's something you don't actually have ready access to put a ruler onto, you can always find that information with a couple Google searches. And here's the version I can afford right here. And you'll notice that I have measurements there for both of them. Well, one of the biggest issues here is that I need to find a scale factor, but I've also got a difference of units. So I need to go back and I need to take a look at converting these converting the units so I can create a proper scale factor. Now, this is where metric becomes so beneficial, and I would definitely highly recommend you work with metric measurements for this very reason right here. Here's a quick little scale up and down the metric chain. All you've got to do is move your decimal point, which is the multiplying by tens or dividing by tens and all that, to go from millimeters to centimeters to decimeters to meters, and then thousands if you're going to go kilometers. And so you can easily just move your decimal around to get your correct units and have everything in the same unit. So I'm going to go to centimeters here. And so you can see there I've got the original measurement of the vehicle and moved out to centimeters. I showed how I got my measurement of my vehicle, put that into centimeters. So now I've got centimeters to centimeters. Now I have the beginnings of a scale factor. At this point, I always put the bigger number on top for this particular example. In your workbook, I put the small one on top, but I've already printed it, so that's not going to change. I'm sorry for that mistake. So the way, I like things to be consistent, but it really doesn't matter as long as you're consistent once you've chosen which is your numerator, which one's your denominator, and keep it, at that point. So here's my little pictures. I'm going to put the large vehicle on top, my scaled model on bottom. I'm going to take those values that I just got, and I'm going to set that up as my ratio here. And notice I didn't do anything. I kept it right as it is. Now, when you're dealing with a scale factor, you're going to be converting your smallest number into a 1, because it's best to work with a scale factor of something to 1. It's the quicker to calculate. And so to do this, I need to take my 7.2, which is my smallest number, and I need to divide that both in the numerator and the denominator. And this is the result when I do that. I get 62.865 over 1. So I got that 1. That's going to be a nice scale factor. You also notice that centimeters went away because I also canceled out the centimeters, because a scale factor, it doesn't matter what unit you're in, the scale factor is going to be congruent for the, I should say it's going to be proportional for your situation. Now, for sake of ease and make it, just easy to work with, let's go ahead and round this, and I want you to round it as well to the nearest whole number. So in this case, I'm going to say my scale factor is 63 to 1. I actually believe Hot Wheels says they're going for a 64 to 1 ratio. I'd have to look that back up, but it's pretty darn close. So I'm glad that my measurements proved to be what they were going for when they create the Hot Wheel cars in the first place. Let's go ahead now that we have our scale factor, and I need to put something in my vehicle, so I've got to have something to scale down. This is going to be one of your 3 items here. And so now I'm going to take this item, and I'm going to take my 63 to 1 ratio. Okay, so in my brand new fancy looking car, what I want to do is I want to go ahead and create a large pizza pie that'll fit in the front seat for me, because brand new car, I need to celebrate with some pie. So what I need to do at this point is I need to look up and find the dimensions of a pizza pie box. Now, if you had the one, left over from Pizza Hut or whatever you had the other night, you can use that. That's totally fine. But to have a diagram, I went and found this information online. And at this point, you're looking at a bunch of different options. Of course, as the fat man, I'm going for the big one, the 15-incher. Thank you very much. So we're looking at 39 by 39 by 4.5 centimeters. Please do pay attention to your unit of measure. That is going to be important. You're always going to need to make sure that you're working in the same units as you're working with anything in scale factor. So now we're looking to actually create the scale model. We need to take the dimensions of the full-size item and apply that scale factor of 63 to 1 for each of these. To do that, we're going to create a proportion for each one. I'm going to start off with the scale factor, and that's going to equal the full size over my scaled size, keeping that pattern once again throughout the whole PowerPoint here. Now the width is going to be the same setup because it's the same measurement. That's okay to do. If you got a square going on, feel free. Just you do need to show the work because one is the length, one is the width. So you do need to show the work and show the proportion for each one. But of course it's pretty easy, just kind of a copy over at that point. Height here of course is a little bit different, but you still got to see the scale factor at the beginning. It equals a 4.5 centimeters over the new height. And we're going to be able to work that out. Looking now at all of our 3 proportions, we just need to go ahead and solve that for our new dimension. We're going to start off with cross multiplication, just like we would any proportion we've done in class. So the L is going to get multiplied by the 63, and the 1 is going to multiply the 39, which is why it's so beneficial to have that 1 there as a part of your scale factor. It makes things really quick and easy to calculate. Now we just got to divide out the coefficient, because 63 is times L, do the inverse operation with division, and that gives you L equals 0.62 centimeters. Now, because 0.62 is a little hard to identify on a ruler, we're going to go ahead and move that at least to millimeters and make it 6.2 millimeters. It's still the same distance, just so it looks a bit easier to work with. Now, once again, with width, it's going to be the same exact steps. Cross multiply, divide by the coefficient, move your decimal, go from centimeters to millimeters by multiplying by 10. No changes. Height over here, still got the 63 to 1 ratio. You now have 63H equals 4.5 centimeters. Do your division of the coefficient and get a 0.07 centimeters. So even when you move that to a millimeter, it's still less than a millimeter. That's a pretty small item. Okay, so I found a piece of 3x5 card that was actually really close to 0.7 millimeters, and I realized at that point there was no way that I could get the correct thickness and have a pizza pie box that open and close, so I was going to have to go with a closed box only option. Once I had the thickness figured out, I went ahead and measured out my 6.2 millimeters and my 6.2 millimeters, as I'm trying to demonstrate there on the pictures. However, there is something I did not pay attention to until afterwards. I'll give you a second to see if you can figure out what mistake I'm making at this time. Let's see if you got it. If you look at my ruler really closely, the edge of the ruler is not 0. There is a portion there that is attached to it before the 0 mark is made. I didn't think about that when I made my markings. And so you're always going to want to go back and double check. Now, another thing I want to talk to you about is I actually decorated it before I cut it out, because being so small, it's easier to decorate if you're able to hold down the large piece of paper. And right now, as you see, my decorations were not all that, but it was still, I would qualify as decoration. And so you can see there on the right, even after I had cut it out, thinking I took into compensation for that little bit I left over, I remeasured it, and sure enough, I had to cut off some more. I got some little scrap pieces there that I had to recut. So double measure your stuff, make sure you got it in the right spots. So as you can see, it's critical to double check your work, even in real life situations. Actually, probably more important to recheck your work in real life situations. As I was measuring it, I realized, wait a minute, I'm too far along the way, and so I had to go back and cut it on both sides. As you saw the scrap pieces earlier, if you look closely, the pizza's kind of been cut off a little bit across the top and across the side, because I did tell you to decorate it before you cut it, which I still hold to that fact, but sometimes you might have to remake it or suffer with a little bit of a cutoff there. You also want to go ahead and compare it back to the original, make sure that you kind of got the same design and layout you were going for. Now, this was a pretty simplistic piece, but it's the basic idea. I got a pizza pie showing, which is kind of really ugly, and then I got pizza written across the top, which is okay. But hey, it is decorated, and that would count as being decorated. So that's all you really need to know about this. It's time to put it in the car. Whoa-bam! Now that looks like it fits perfectly on that front seat, just like any large pizza box should. Here's another angle of it. And there you go. I've shrunk down a full-size pizza box to fit inside of a Hot Wheels car, and it's perfectly accurate at a scale model of 63:1. Now, it is now your turn. There's going to be a progress check along the way. During the Unit 7 exam, I want to take a look and see how you're coming along. So for A Day, that's going to be February 5th. B Day is going to be February 8th. I want to take a look at your scale model workbook. I don't actually want to see your project. I just want to see your math part. For a full 100 on that day, I want to see that the entire front page is filled out, the scale model's figured out. The scale factor's been figured out. You know exactly what you're working with there. On the next 3 pages, I would like to see that you've got the item listed and that you found the dimensions for it. Hopefully you've got the proportions set up and it's not that far to go from solve it from there. So I like to see the complete packet top to bottom fully finished, so that way I can try and spot any mathematical errors you made along the way before you go any further with actually making the project. But at the very least, I want to see that you've got the measurements and the items for the other 3 pages. But definitely the front page has got to be filled out. I got to know that you've got your scale factor to work with. As far as the final due date, it's going to be February 11th or February 12th for A Day and B Day respectively. That's going to be right before Valentine's Day, and you should be able to keep the project and take it with you. So if you're culinary and you're trying to scale up a Reese's cup, which I've heard about, and I just can't wait. That way you have it available for a Valentine's banquet maybe, or something like that. If you've got a sibling or a family member that's really into My Little Pony, maybe you're going to play Rarity and make a couple outfits or something for the pony. I don't know. This is totally your thing to do. You're able to choose anything that's of interest to you as long as it's wholesome and it's legal, and just have fun with it. I do want to also possibly throw out there that you could be looking at a Super Bowl party this Sunday coming up, at which point you could turn your entire table into a football field and make scaled down models of the end goalposts and scale model of the football, or maybe just mark off the table with duct tape. Not duct tape, but maybe masking tape or something. Your mom would probably kill you for duct tape, but masking tape's okay. And take pictures of it and stuff like that. I'd be very interested to see that kind of stuff. All of that can be done with a scale factor and be done perfectly and done well. So have it something that can be fun and enjoyed by a lot of people, and I just look forward to seeing what you come up with.